Good morning. My name is Camila. Now, this video is going to be about the history of the planet. I hope that you will enjoy the information and I hope that this one is going to be a good idea to remember about our history, our planet. We have to take care about the planet. Do you remember that? Okay. The history of the Earth is the story of how the planet formed and how life has evolved on it over time. Earth's history is studied using the geologic time scale, which divides time into intervals based in stratigraphic analysis. Formation: Earth formed around the Sun over 4.6 billion years ago. The planet formed from a cloud of gas and dust called the solar nebula. The solar nebula contracted and rotated, forming a flat disk. The disk broke up into rings, and gravity caused matter to condense around dust particles. Small fragments collided to form larger fragments, including the Earth. A gland impact with another planet created enough debris to form the Moon. Life. The first signs of life on Earth were simple prokaryotic bacteria. Life likely originated in water because it provided more temperature stability and currents for movement. Aquatic plants and animals evolved 600 million years ago. Terrestrial plants and animals evolved 400 million years ago. Dinosaurs lived during the Mesozoic era, which lasted from 65 and 250 million years ago. Homo sapiens, the Homo sapiens, the early ancestors of human, evolved 2000 millions and 300 million years ago. Each has experimented five major mass extinctions, often referred to as the Big Five. The most recent mass extinction, which wiped out the dinosaurs, occurred about 60 million years ago. Okay, now I'm going to talk about history of Earth. I hope you will enjoy it as I am enjoying this item. Just a minute, please. Okay, history of Earth. I'm gonna try to read it as clear as I could. Okay, it's a very long history. Okay, the geological time scale, as defined by international convention, depicts the large spans of time from the beginning of the Earth to the present, and its divisions chronicle some definitive events of Earth history. Earth formed around 454 billion years ago, approximately one third the age of the universe by accre- accre- accretion from the solar nebula. Volcanic outgazing probably created the primordial atmosphere and then the ocean, but the early atmosphere contained almost no oxygen. Much of the Earth was molten because of frequent collisions with other bodies, which led to extreme volcanism while the Earth was in its earliest stage. Early Earth, a giant impact collision with a planet-sized body named the Thea is thought to have formed the Moon. Over the time, the Earth collided, causing the formation of a solid crush and allowing liquid water in the surface. The Hadean Eon represents the time before a reliable fossil record of life. It began with the formation of the planet and ended 4 billion years ago. The following Archean and Proterozoic eons produced the beginnings of life on Earth and its earliest evolution. The succeeding eon is the Phanerozoic, divided into three eras: the Paleozoic, an area of arthropods, fishes, and the first life on land; the Mesozoic, which spanned the rise, reign, and climatic extinction of the non-avian dinosaurs; of the Cenozoic, which saw the rise of mammals. Recognized humans emerged at most 2 billion years ago, a vanishingly small period of the geological scale. Wow. The earliest undisputed evidence of life on Earth dates at least from 3.5 billion years ago, during the Eortian era. After the geological crash started to solidify following the earlier molten Haden Eon. There are Microbial mat fossils such as Stromatoliths found in tree period 48 billion years old, sandstone discovered in Western Australia. Other early physical evidence of biolo- biogenic substance is graphite in period 7 billion years old. Metasedimentary rocks discovered in southwestern Greenland, as well as remains of biotic life found in 4 period 1 billion year old rocks in Western Australia. According to one of the researchers, if life arisen relatively quickly on Earth, then it could be common in the universe. Wow, it's not easy to read that, but I'm trying to. Okay, sorry for the mistakes. Photosynthetic organism appeared between 2.2 and 2.4 billion years ago and began enriching the atmosphere with oxygen. Life remained mostly small and microscopic until about 580 million years ago, when complex molecular multicellular life arose developed over time and culminated in the Cambrian explosion about 538 period 8 million years ago. This sudden diversification of life forms produced most of the major phyla known today and divided the Proterozoic eon from the Cambrian period of the Paleozoic era. It is estimated that 99% of all species that ever lived on Earth over 5 billion have gone extinct. Estimates on the number of Earth's current species range from 10 billion to 14 million, uh, of which about 2 period 2 1 2 period 2 million are documented, but over 86% have not been described. Um, the Earth's crush has constantly changed since its formation, as has life since its first appearance. Species continue to evolve, taking on new forms, splitting into daughter species, or going extinct in the face of ever-changing physical environments. The process of plate tectonics continues to shape the Earth's continents and oceans, and the life they harbor. Okay, this is the part of the history of the Earth. The history of the Earth can be organized chronologically according to the geologic time scale, which is split into intervals based on stratigraphic analysis. Mhm. Yes. Okay. Finally, the solar system in formation. Okay, I'm going to tell you about this. It's not so much longer, but I'm going to read about the solar system formation. Pay attention, please. And this is the end of the video. What is the final item? The standard model for the formation of the solar system, including the Earth, is the solar nebula hypothesis. In this model, I'm going to show you that for a few minutes. This model, the standard model from the formation of the solar system nebulae the Earth, is the solar nebula hypothesis. In this model, the solar system formed from a large rotating cloud of interstellar dust and gas called the solar nebula. It was composed of hydrogen and helium, created shortly after the Big Bang 13.8 GA billion years ago, and heavier elements ejected by supernovae about 4-5 GA. The nebula began a contraction that may have been triggered by the shock wave from a nearby supernova. A shock wave would have also made the nebula rotate as the cloud began to accelerate its angular momentum, gravity, and inertia, falling into a protoplanetary disk perpendicular to its axis of rotation. Small perturbation due to collisions and the angular momentum of other large debris created the means by which kilometer-sized protoplanets began to form orbiting the nebular center. Let me breathe. The center of the nebula, not having much angular momentum, collided rapidly. The compression heated in it until nuclear fusion of hydrogen into helium began. After more contraction, a Tauri star ignited and evolved into the Sun. Meanwhile, in the outer part of the nebula, gravity caused matter to condense around densely perturbations and dust particles, and the rest of the protoplanetary disk began separating into rings, and a process known as runaway accretion successivity ledger. Fragments of dust and debris coupled together planets, from planets. Earth formed is that much the manner of about 454 billion years ago, with an uncertainty of 1%, and was largely completed within 10 to 20 million years. In June 2023, scientists reported evidence that the planet Earth may have formed in just 3 million years, much faster than the 10 on 100 million years through the earlier. Nonetheless, the solar wind of the newly formed T Tauri star clear, cleared out of most the material in the disk that had not already condensed into larger bodies. The same process is expected to produce accretion disks around virtually and newly forming stars in the universe, some of each giant planet. The proto-Earth grew by accretion until its interior was hot enough to melt the heavy, side profile metals, having higher densities, and silicate. Silicates these metals sank. So-called iron catastrophe resulted in the separation of a primitive mantle and a metallic core only 10 million years after the Earth began to form, producing the la- later structure of Earth and setting up the formation of Earth's magnetic field. G.I. Jacobs was the first so- to suggest the Earth's inner core, a solid center distinct from the liquid outer core, is freezing and growing out of the liquid outer core due to the gradual cooling of Earth's interior. About 100 degrees Celsius per billion years. Okay, I hope you will understand what I have been reading about the history of the Earth. I hope that you will enjoy this item, and I want you to subscribe and ring the bell. Turn on the ring of the bell. Okay, to know, to realize that I am setting new content Um, I want you to give me advices or questions about the topic. Now is I am happy to talk to you, and this is the first video about something in English. I hope you. I repeat. I will hope that you understand what I said about this item. Um, Thank you for listening to this time. I will return soon with another history, and I will try to find another theme that will be easier to read and describe. Okay, thank you. Thanks a lot about the time you spent with me, and welcome to the new subscribers. And thank you for subscribing the people who staying with me since December of the last year. Okay, have a nice day, and I hope so you will be very fine.